This is section 5.2, addition and subtraction of polynomials. We're going to get back to rules for exponents, but we need to talk about polynomials first so that we have something to work with when we use these rules later. So polynomials means polynomial, many numbers, and a monomial, here's some examples here, it's just a collection of numbers and variables being multiplied or divided together, basically. So this is a monomial, this is a monomial. These are also sometimes just called terms. Down here, polynomial, mono means one, by the way, so this is one term and one term, a one-term polynomial. Down here, this is a polynomial. This is what we call a binomial because there's two terms. There's an x and a 2. Notice these are separate terms because they're split with a plus or a minus. Up here, no plus or minus. Up here, the minus is in front. It just means it's negative, but these values aren't split. This is all multiplication, multiplication. So here's two terms, a binomial. And here, what we have is a three-term polynomial called a trinomial. 1, 2, 3 terms. If you just want to identify polynomials, the main thing is that the variables cannot be, the variables cannot have exponents that are negative or fractional. The variables can't be in denominators or any weird place, really. They can't be in under square root. They can't be in a denominator, absolute value. Basically, you have to have, like this one here, regular old variables to regular old powers, right? So this is a polynomial. This is a monomial because, again, it's just one term, and all the powers are nice and kosher, so we call that a polynomial. I'm just going to give it a check here. It's a polynomial. The second one, same idea. We have multiple variables, but each variable has nice positive powers. We don't have to worry about anything else, so this is also a polynomial. This bottom one, though, has a couple problems. Actually, it has three of them. It has a negative exponent. Automatically, it's not a polynomial. It has a variable in the denominator. Automatically, not a polynomial. And it has weird things going on with the variables, like they're underneath the square root. Automatically, not a polynomial. So, three different reasons why it's not a polynomial. Okay, like terms. Like terms are terms that have the same variables with the exact same exponents. So, for example, 3x squared and minus 2x squared, these are like terms. Negative y cubed and 2x cubed, these are not like terms. They have different variables even though they have the same powers. The whole point of this is you can actually add and subtract like terms. If they're not like terms, you can't add or subtract them at all. Okay, so for example, 3x squared plus 2x squared, these are like terms because they both have x squared, same variable, same power. And to combine like terms is really, really easy. All you do is add the numbers in front of the terms. These are actually called, or in front of the variables. These are actually called coefficients. So 3 is in front of the variable. This is the coefficient. 2 is the coefficient. If you add them, 3 plus 2, you get 5. And you just keep the variables exactly the same. So it makes sense. 3x squared plus 2x squared gives you 5x squareds. That's how you combine like terms. So thankfully, adding and subtracting polynomials is all about combining like terms. So in this first example, we have 3y squared, 4x, and minus 2y squared. This 4x is lonely all by himself. It's just going to stay 4x. But y squareds, these are like terms, so we can combine them. And again, focus on the numbers in front, a 3 and a minus 2. 3 minus 2 gives us 1, so we just get 1y squared, which, by the way, we can just write as y squared because you don't need the 1 in front. And then again, that 4x is just along for the ride. This is the best we can do in this case. Right, so whenever you're adding or subtracting polynomials, combine whatever you can and just kind of bring the rest along for the ride. Same idea down here. We've got some x squareds and x squareds. Those can combine. xy and xy, those are also like terms, so those can combine. These parentheses, by the way, aren't really doing anything right now. It's just saying, hey, this is the first polynomial and this is the second one. Once we're adding, we can actually just drop those and ignore them. So let's go to the adding. 3x squared and x squared, don't forget there is an invisible 1 here, so we really have 3x squared plus 1x squared. So that's going to give us 4x squared. That takes care of our x squareds. And then for our xy's, we have a minus 1, don't forget, invisible 1, minus 1xy and 4xy. A minus 1 and a 4 gives us a 3. It's positive, so we're going to do plus 3xy. And again, this is our final answer because those things are not like terms, right? We can't combine x squareds with xy's. Subtracting is pretty much the same thing. The only catch is, because you have a minus here in parentheses, this minus actually has to go to both of these. So basically we say distribute the minus first. So I'm just going to kind of draw that in for you. So I'm going to rewrite this problem as 2x squared minus y squared, and then when I distribute this minus, it'll be a minus x squared, and the second one, it's a minus and a minus, so it's actually a plus 4y squared. Right, so all I did was distribute this minus through, and now we're ready to actually combine our like terms. X squared is x squareds, y squareds and y squareds. So 2x squared minus x squared is just 1x squared, which we're going to write as x squared. And then minus y squared plus 4y squared, that's going to be a plus 3y squared, minus 1 and 4. And that's it. Can't combine these, so that is our final answer. Same idea down here. This minus is going to go to both pieces, so let me rewrite it. We have a 5x squared, oops, it's a bad x, 5x squared minus 3x plus 1, and then minus minus, this will be a plus x squared, and then a minus plus 1 will be a minus 1. That's what it looks like after you distribute that negative. And now combine your like terms. Looks like we have some x squareds that can combine. 5x squared and 1x squared will give us 6x squared. We have a minus 3x. Notice the 3x, there are no other regular x's, so it can't combine with anything. And then the plus 1 and minus 1 just cancel each other out. So this is actually our final answer. So that's it. Hope this helps. Let me know if you have any questions.